arc length and parametric. So we have a following situation. We have parametric curve C. And it's given to us by its parametric equation, x equals to x of t, y equals to y of t. So a graph might look something like that. Then we want to pick 2 points on that curve, which starts at t equals to a and t equals to b. And we want to find what is the length at arc between these 2 points. To find the length, we'll do our usual thing. So firstly, we find approximation to what we are looking for, and we take limit of approximation, and we're going to get the answer. So let's look one more time. So t equals to a, t equals to b. So we have t is between a and b. And we're going to divide the interval between t equals a, t equals to b into subintervals of small arc of delta t. So that is t0, which is t equals to a, then t1, then t2, and so on. The last one, tn. So correspondingly, our parametric curve will be divided into smaller pieces. Then we want to look for ith piece, which might look something like that. And then let's say that piece, which is small and looks like this, a little bit bended, is approximately the same as if we take the same piece, but we connect the endpoints by a straight piece. The good thing about that straight piece is we know what horizontal change delta x and vertical change delta y. So we should be able to calculate that approximation, and that using the Pythagorean is going to be delta x squared plus delta y squared and the square root. So what we conclude is that ith piece, length of I piece is going to be approximately equal to the square root of delta x I squared plus delta y I squared. I'm going to write down some index delta x I, delta y I, because that's as happening on ith piece. So then the total length is going to be approximately equal to sum of our approximations, delta x I squared plus delta y I squared I from 1 to m. Then we take limit of that approximation when delta t is approaching 0. We want to take as many divisions of interval between t equals a to equals to b possible. So delta t is approaching 0. So at the end, we're going to get total length. So our approximation is getting better and better. So eventually it's going to be exactly equal to total length. So, recall what is going on. Limit of sigma becomes integral. Square root delta x becomes dx, delta y becomes dy. Keep squares, and we start at t equals to a, and we end at t equals to b. We're almost done. You notice that our integral looks a bit odd. So it's missing differential. So it's missing t in our case, because we want to differentiate with respect to t. So to keep it balanced, we also divide by dt. So then we're going to bring that dt under the square root. So we're going to bring that dt under the square root. So we're going to get integral a to b, integral from a to b, square root. We're going to get dx dt squared plus dy dt squared. So that parametric C, which has parameterization x equals x of t, y equals y of t, on the interval when t is between a and b can be calculated by using different integral from t equals to a to t equals to b, square root derivative of x with respect to t squared plus derivative of y with respect to t squared. That sum is under square root dt. That's the formula which we're going to be using to find the arc length in the parametric form. We have a parametric curve given to us. X equals to t minus sine t, y equals to 1 minus cosine t. What we want to do is find the length of the curve. T is between 0 and 2 pi. So we're going to be using the formula which we derived a couple minutes ago. So to use that formula, we need to find dx dt, which is derivative of x with respect to t. Derivative of t is 1, derivative of sine is cosine. We're going to find derivative of y with respect to t. Derivative of 1 is 0, derivative of cosine is negative sine, so minus minus gives us plus cosine t. We're going to substitute that into integral. So limit of integration t equals to 0, t equals to 2 pi, square root 1 minus cosine t squared plus sine t squared dt. And all that is left now is just to evaluate the definite integral. So that's what we're going to be doing. So we're going to do integral from t equals 0 to t equals to 2 pi. We're going to simplify that expression by square root. So 1 minus 2 cosine t plus cosine t squared. That is square of difference plus sine of t squared dt. Cosine squared plus sine squared equals to 1. T equals 0 to t equals 2 pi. 1 plus 1 is 2, so 2 minus 2 cosine t. That we can factor out 2 out because it's under square root, so we're going to take square root of 2 outside of integral. Minus cosine t dt. Now we have to recall some trig identities. Recall that sine squared t equals to 1 minus cosine of double argument divided by 2. So from here, we're going to get 1 minus cosine of double argument equals to 2 sine squared t. So for our formula, we want to figure out what is cosine of t equals. So treating t as double argument, so we're going to get equals to 2 sine squared, and because we're treating t as double argument, we're going to get 2 sine squared t over 2. So that's the formula which we're going to substitute inside of the integral. To get square root of 2, t equals to 0, t equals to 2 pi, square root of 2 sine squared of t over 2 dt. So we're going to get equals square root of 2 times square root of 2, t equals to 0, t equals to 2 pi. Square root of square, we have to be a little bit careful. Sine of t over 2, because square root of square is equal to absolute value of expression. Now notice that when t is between 0 and 2 pi, sine of t over 2 is positive. So in our case, that expression which we have here inside of absolute value is positive, so we don't have to write it. We don't have to write down absolute value, so it will be just sine of t over 2 dt, integral t equals to 0, t equals to 2 pi, square root of 2 times square root of 2 is 2. 2, antiderivative of sine is negative. Cosine of t over 2, because it's t over 2, we will have extra 2. And do limit of integration t equals to 0 to t equals to pi. Substitute upper bound, substitute lower bound. So we're going to get 2 times negative 2 cosine of pi is negative 1 minus 2 times 1. So final answer in our case is going to be 8.